All right, so we have here some picture which is roughly like level curves for g of x and y. And, oh yeah, I'm doing the 16.1 number 3, give or take. And give or take because I drew the crappy picture. And they told me to over/underestimate what? Something about g of x and y? The what?
Yeah, it just showed, figure 16.6 shows contours and find an over and underestimate for the interval of g of x times d of a.
Okay, so I'm actually introducing a little notation that I haven't talked about, right? So they're integrating over some region, right? Why not an A and a B? Yeah, because like an A and a B would just be a one-dimensional object, right? But I'm integrating over some kind of a rectangle, right? So what's the D what?
Area.
Area, right? So I might think about this thing as like delta x, delta y bits, right? You guys kind of with me on that?
Mm-hmm.
And this thing I'm going to kind of sum, right? And then these should be like g of x star comma y star kind of thing. You guys with me on that? Okay, so I need to chunk this up. Did they tell me how many chunks I have to use? Oh yeah, they say using delta x as delta y is 2. Okay, so where are my little rectangles then?
There'd be 2 in width and 2 in height, so just in between each mark you got there.
Yeah, so I just kind of need to go like this, right? So here's my first rectangle, here's my second, I guess, right? Like there's no like real consistent numbering scheme here, right? But either way, this thing's split into 9 little rectangles. You guys with me?
Yep.
Okay, I'm going to label those rectangles something. I'm going to do, this is the first rectangle. This is going to be the second first rectangle. This is the third first rectangle. This is the
1, 2.
first, second. Good, perfect.
2, 2.
So 2, 2,
I mean 3, 2.
3, 2. And then these are the 1, 3, 2, 3. Oops, 2, 3. And 3, 3 rectangle. You guys cool with that? Okay, so let me look at the 1, 1 rectangle. So I need some stuff about the 1, 1 rectangle. So what's the area of the 1, 1 rectangle?
4.
Yeah, it's 2 by 2, so it's got a total area of 4. Okay. What's an overestimate for the height in the 1, 1 rectangle?
When I was doing that, I was assuming that'd be like a 0.9 or a 0.8, but if you're taking an overestimate, how do you find the value in that? You just take
Where it's highest, and just assume it's everywhere? Can't you say 1?
Yeah, exactly. Try to pick the highest point in there, which is something over 1, and assume it's everywhere. So it's something over 1 and under 2. You guys see that?
1.3.
Better.
It's just an estimate. It's going to be bad. Right? Because in here, it could get to like 1.9 up in that corner. You guys see that?
Is it an overestimate of the maximum or an overestimate of the area?
It's gonna, so I'm overestimating the maximum. And when I multiply that by the area, that's going to give me an overestimate of the volume under there. You guys see that?
Mm-hmm.
This is not necessarily the way the book does this. it would be perfectly reasonable for you to say that 1.5 is an overestimate here. You guys see that? Because it probably is. I know for a lot of this rectangle, this thing is under 1 unit high. Estimating that saying that 1 is an overestimate is probably a little bit of an overreach. 1 is probably a good estimate, but not a good overestimate. Does that make sense? So what's your good underestimate?
0.
Perfect. 0 is definitely a good underestimate. Because I know it's under 1 and I didn't see a little bit of -1 contour line in there. So whatever's going on, the minimum in there is between 0 and 1. Okay, so for your 1, 2 rectangle, I don't know why I decided to go up.
Oh, hold on.
So the 1, 2 rectangle, right? The area is still 4.
Yeah, the area is 4, but
And an overestimate is
2.5
3.
or
yeah,
yeah, I guess.
3 is kind of not in there, right? But it definitely gets over 2 in there. So an overestimate would be 3. An underestimate would be
0 again.
0 again. You guys cool with that? Okay, how about the 1, 3 rectangle?
Always an area of 4, isn't it?
So it's still area of 4, right?
all of them will be area 4.
Good. All of them will be area 4. And the over on that one is
4?
I'd say 3.
3.
Does it hit the 3 line?
I don't know. You'd have to look at the picture.
It goes over.
Here, if we just assume it does, right? If you look in the picture in the book's a little different. So, given this picture, I'm going to say 3 is an overestimate. In your book, you'd probably say 4.
Okay. Still 0.
And an underestimate is, yep, it still goes below 1, so I'm still going to underestimate at 0.
So you do that for every square on the graph then?
Yep. So let's go through and just toss the rest in here. I don't have another good color. So let's see, in your next row, so for the 2, 1 rectangle, you got an area of 4, right? Your overestimate is 2, and your underestimate is
0.
0. In the 2, 2 rectangle, your area is 4. Your underestimate is 1. Oops, sorry, underestimate's 1. And your overestimate is, looks like 3 from this picture. And in the 2, 3 rectangle, your area is still 4, right? And your overestimate is 5. And your underestimate is 2. And then in the third set, so our 3, 1 rectangle, area is 4. Overestimate is 2. Underestimate is 0. In your 3, 2 rectangle, what do you got?
4 is over, 1 is under.
4 is over, 1's under, and it's an area of 4? Yeah, that seems legit. And then your 3, 3 rectangle, area is 4, overestimate's 6, underestimate's 3. Okay, now there is actually something I wanted to talk about here, which is why I did this whole business, right? So to overestimate the volume, what do?
You do all the overs multiplied by their area and add them together.
Okay, so take the overestimate, multiply by the area. So my first one, right, is 8, and then to that I want to add, what, 12, and to that I want to add 12, and kind of so forth, right? That's all good with that? Okay, and for my under?
Same but with the undervalues.
Good, same with the undervalues. So you do your area times your height. So that'd be 0, 0, 0, These are going to be easy, right? 0, 4, 8, 0, 4, 12. Oops, there's a 0 on there. Add these up, and you get something like whatever you get. Cool? You guys see that? Okay, the thing I actually wanted to talk about here is, was there anything special about the order in which I did this?
No.
You guys see, what was the order in which I did this?
Over first, then under.
I meant more like the order in which these things are added.
You did it by rows, or columns, actually.
Yeah, so I went through and I said, okay, here's a column. I'm going to get the, right? So this thing here, right, these first 3 numbers, what's that guy?
Yeah.
Yeah, that's like the volume under that part. You guys see that? Like, that's the volume under the function above this column. And then I'm going to do the next 3, right? These guys are the volume above this column. Is there anything special about doing the columns first versus doing the rows first? No, not at all, right? That's weird. I mean, it's not weird here, right? Like, who cares? If you want to add them up, like, do this one first, then do this one, then do this one, then do this one, this one, this one, and then these 2, and then that one, fine, sure, have at it, right? But when we start doing this procedurally, what that'll mean is you can swap the roles of x and y without worrying about it too much. Right? You can add up the x's first and then add up the y's, or add up the y's first and then add up the x's, and who cares? You guys see this?
Okay.
Cool. Did that kind of answer your guys' question?
Well, yeah, because I was on the ones where you have like a graph or a chart full of numbers, you kind of exclude like an L-shaped portion of them, like if you're doing the minimums or the maximums, depending on which direction you're going. I was doing it with that and getting really small values, like way smaller than the answer in the back of the book. So.
Yeah, so the kind of exclude an L-shaped bit or exclude an L-shaped bit, that's really because the functions that they've given you in those examples are like increasing or decreasing in kind of obvious ways. It doesn't, to get the best over and underestimate, you want to like, there's maybe like a little more thinking you could do with a picture than you can do with that chart of numbers. Does that kind of make sense? Like, because here, right, to look for the underestimate here, I can go someplace other than like this corner or that corner. And that's what that L-shaped thing is doing. That's you picking like top lefts or bottom rights. But I have more options than that in the pictures. Kind of with me? Turns out it doesn't matter much, right? Because as you slim this division down to 0, right? Like as you make these cuts smaller and smaller, there'll be less variability between your choices anyways. You guys see that?